Hello and welcome to the third video in our Python Made Easy data series. In the last video, we set up our Anaconda environment, we set up our Jupyter Notebook environment, that's the IDE, and we basically wrote our first line of code. We also took a brief look into our dataset that we'll be using throughout this series. And in this video, we're going to take that a step further, right? We're going to use some tools in Python, some libraries in Python to properly look into our data set. We're going to do what's called data inspection. That is, a form of exploratory data analysis. We're going to really get to know, essentially just getting to know what kind of data we are working with, the nature of it, the shape of it. And obviously, before we do that, we have to obviously load it into the Jupyter Notebook environment. So we're going to learn how to load our data into the environment as well as properly, getting to know what we're working with. Let's get straight into it. This is exactly where we stopped in the last session. Wrote our first line of code and that. So as I said, we have to load our data set into the environment, then load the bar into it. So how do we load our data set into the environment? We have to utilize a library called Pandas. And what is Pandas? In Python, there are libraries. Libraries are basically sets of functions that help with various tasks in the Python environment, the Jupyter environment, or whatever environment that you're utilizing the Python in, right? Tasks ranging from mathematical tasks to, let's say, organizational tasks like organizing files in your system, or even scraping tasks from website. Different ranges of tasks that Python can help with. So the Python libraries can help with. Then a kind of Python library that helps with manipulating and transforming data to the user's needs is Pandas. Pandas help with data collection, data transformation, wrangling, and it even has some inbuilt mathematical functions. So think of it like Excel but in steroids, right? It really helps with a lot of a wide range of functions, right? So before you are able to use pandas in the Python environment, you have to import it. Any library you want to utilize, you have to import that library. And so we're going to basically import the library. So just import pandas. I'm going to give it an alias, which is going to be PD. That's a typical alias for pandas worldwide. Like, that's what is used. So if I run this code, shift enter, or just press my play button, it's going to think a bit, then it's going to see one. This one means that in this current session, it was the first line of code to be run. Although I ran this code in last class, I've not rerun it for this class. So basically, if I want to rerun it, I can just press play, and it's going to be the second code around this. So that was basically what the numbers mean, in case you are wondering. So I'm going to touch most of these things throughout this session, throughout this series. So we have imported our pandas. The next step is going to be to then load our file. To load our file inside the pandas library, we're going to use a function called read CSV. Now, looking into our file, you can notice that we're going to utilize this file here as a CSV file, comma separated values. So basically, we're going to read our file by saying PD, that's the library. We're going to run a function inside the library as read underscore CSV. Then underscore CSV, then basically the file name. I don't want to, write that out. You can just copy, come here and paste. But it has to be inside the quotes, right? So it has to be inside the quotes. And basically, we can read it, but if you just read it, there's no need to read it. Like, I basically want to put it inside a container, a variable. right? So I'll call that variable. The typical variable for a Python, a Pandas CSV is called a data frame. That's basically like a spreadsheet kind of um, container. So basically, df equal to the function that reads the file in our computer. And if you notice, okay, there's a little issue. No such file or directory. So slight mistake. So it's not just going to be the file. This will work if the file was in your what's it called, root, the root of your drive, but it's not, obviously. So I have it's in, you know, yeah. This my mine is located. So it's still going to be inside my quotes, but location of my file is D this. So yeah, uh, then I can then at this point I can then add include the Excel file, the CSV file, sorry. But based on this, I want you guys to also notice something. Let me just on it. So yeah, you can see that there's another error that comes up with this dash, the backward slash. Essentially, the backward slash, it's to escape to a different line. If you print out something with the backward slash, it escapes to the next line. So we don't want that. We want it to read it as is. So you add R for the quote. Um, that will read, that's read our um, file for us. I allowed all these errors, number one, so you see that nobody's perfect. Human error can occur. It's easy to fix. It's fixable, and I just fixed it in your front. And the next thing is to for so you can see that. So you can also learn the reason why I add the R. Why the R is there. I don't want to just use the R. I use the R so Python can read this dash as is. Usually, the dash takes whatever you're printing to the next line. I do not want that. Check out our data frame. We have loaded it, so let's check it out. How do you check it out? Use a function called head. So df the head will show us the first 5 rows of data set, and this is it. So it has been successfully loaded into our environment under the alias or under the container df. And yeah, so it's time to properly explore or inspect it. This method is the most crucial diagnostic step when it comes to data inspection or exploration. It gives a brief overview of what your data is really about, the shape of your data, just basic information about your data set. Not basic and important, to be honest. So it's df.info, basically. So, and you can see how many, yeah, essentially how many cells in each column that are occupied, that are not null. 30 for my case. That means, and some are 28. So with the fact that most are 30 and I'm seeing it 28 means that um, I know that that has missing cells, right? Then data type, you can also see data type. Object is like text. If you're coming from Excel, object or Power BI, object means text or letters, somewhat. Floats obviously is decimal numbers. Object is text. Integer 64 is whole numbers. Object text. So yeah, different data types that we're working with. And yeah, this will just give an overview of all the data types that are in your data set. You can just at once you can see there's only one float, 3 integers, and 6 objects. That's 6 text. So basically, this is it. If you want to see the shape of the data that you're working with, data frame or the table that you're working with in Pandas, you have to do df.shape. 30 rows, 10 columns. Good to know. Moving on, if you want to really see now, if you want to get mathematical, maybe it's a survey kind of data set that you analyze, right? Or just you need mathematical metrics, right? So you just do df.describe. Yeah, the count, and as you can see, it's only worked on the columns. Numerical columns. It did not include the text or the objects. So the mean, the average, that mean, standard deviation, the minimum, the maximum, the different quartiles, right? If you want to include your text or object values, for whatever reason, include equal to, is it include all? Checking with you guys. So you can see this obviously okay. If you must not know everything, some things you can. I pressed Shift Tab to really look into what can be, modified. Or it has now included the object or the text columns, ID. When it comes to standard deviation, all these things, obviously, you can't find that in text. You can only find the count, a number of unique values for the text columns. So it doesn't really make sense for text values, honestly, because the mathematical summary doesn't make sense for text values. So yeah, there's no need to include all. Just to describe it makes sense. And now you can also look into specific columns. Let's look into the object columns. What I like to do first of all is, now we have seen basically what are uh, the data frame in total is about. We've seen the existence of null values in each column. We've checked out the shape of our data frame, and I've really looked into the mathematical summaries. You know, whatever. That's just because, just to show you guys what we could do. So, but now, if I want to really clean this data set, I have to ensure that the ID, starting from the ID is unique. I have to check if my ID is unique. If my ID isn't unique, I would have to work on that in the next class, which is when we really get to clean it. So I want to really check if my ID is unique. Then I'll look into each column, each text column, to just check them out and see if maybe they are duplicates, or maybe there are issues with the formatting. Now to check if the ID is unique against next class is df, focus on one column, you have to use square brackets. So I'm basically trying to call one column now, like my ID column. Let me first of all call it out so you guys will see. It's a call out column. To check if it's unique, please depends if the formula code is a function code is unique. I want to see true or false. True means that it is unique. So that's fine. Your ID, your unique, your identifier for each row, which is what the ID is all about, should be unique, right? Because one ID is representing one customer, and different metrics that define the customer, number of purchases, maybe name, age, different things. People can have the same name, people can purchase the same thing, same amount, but they can't have same ID. So ID is what classifies all the other categories, so on. So you get why it should be unique. Now, moving on from that, my ID is unique. Now I just want to look into each and every category, which is a object column, to just explore it. I'm going to use something called value counts. Right. So I think The ID is okay. I'm going to enter my gender. So df gender uh, dot value counts. I think I should put on search. So male 15, female 15. Simple. Uh, Earlier we found out that only our age has missing values. And obviously the way we found that out can be confusing based on, it's not really, I did the minus in my head. Just told you guys. So to really check the number of not null values or like null values in your column, in your data frame is very simple. The vector is null or some just to check. So is it so two only age? I want to title my cell as well. So here I was basically rechecking for nulls. Is a comment that starts with hashtag. So basically simple. Checking if ID was unique, exploring the columns, we're checking for nulls. Yeah, so that's fine. The next column that we're working with, we want to just explore, because we're still exploring columns over here. Is same thing here, but for the customer location. The gender looked good. Customer location. So Lagos, Abuja, Port Harcourt, LOS. So that's what we're going to be working on in the next class. But we're cleaning that. So Lagos, LOS is supposed to be the same thing. So that's an issue. FCT and Abuja also. You have to clean that. Port Harcourt and PH have to clean that. So you see why the clean is important. Let's enter the tenure and months. So we're still exploring columns, to be honest. So we have to do this. It takes time. This is one of the most hectic stages of data analysis process. So as you can see, this is good to go. Tenure months, is was it part of our numerical value? So I'm not even supposed to. That was my bad. So the next thing that we are checking is we're exploring columns, um, text columns. Is not tenure or months. It is payment method. Checking payment method. Checking payment method. Checking payment and payment method shows us that card, bank transfer, USSD, card appeared twice. So we have to work on that. Just next class, we clean it. The next class is for cleaning. So another thing that we should do, obviously, the next one after payment method is last purchase dates. Dates. And we can see there's an unknown date here, right? Unknown date. We should probably clean that. We are going to clean that. That's part of what we're going to do. We have to clean that up. And the last but not the least is total customer spend. I believe that is in uh reality in object. And that's also an issue. Sorry. That's also an issue because they have to understand that our customer spend. Also, the fact that our date is in object is an issue. Our date should be in date format. We will clean that up the next class. But it's good that the fact that it was in this format allowed us in this case to see that it's literally a write up called unknown dates, which is not what we are looking for. You understand? So total customer spend is the next one. Let's just check that out. Let's check that out. Total customer spend is an issue because the total customer spend is also giving me random values. Random value giving me dates like it's rare. So it's very this is good because we are going to work on this in the next class for fact. All of this. So yeah, we just basically explored our data set, checked the initial rules, checked out what the content was talking about, the nulls, not nulls, just the kind of data that we're working with. We now went on to check the shape, check the a mathematical summary just because we didn't actually utilize it in this case. Uh, checked our ID because confirming if the ID was unique is very important in data inspection or exploration. Then we then started to look into each and every other column based on the fact that we found out that only our age had missing values. We could freely then look into uh, other columns for the purpose of confirming whether the formatting was correct. And we found out that the location has issues with the formatting when it comes to Lagos, FCT, all these things are short forms. Their full forms are already here. So their long forms are already here. So we have to work on that. When it also came to the payment method, card appeared weirdly uh, in lowercase when it should be in uppercase, like in proper case, like at the initial and occurrence of it. And also date, we found out that there was a place that it was literally written out unknown dates, which is not right. Then last but not the least, and obviously the date was not in date format. It's something called a date format, right? Pandas. So the fact that it was not date, that's also something that we have to fix. That's something that we found out during our column exploration. And last but not the least, we entered the total customer spend, and it just looks wrong. So we'll get to the bottom of all these problems in the next class where we get clean up the data set for analysis. So stay tuned.